Okay, today we're going to go over chapters 5, 6, and 7. So the first thing we look at in chapter 5 is stored procedures. What is a stored procedure? Basically, a stored procedure is an object that contains a group of SQL statements that are compiled and can be reused at any time. So there's many benefits to a stored procedure, like faster runtime, improved performance, and reusability of code, and less traffic between the client and server. We're going to go over create, run, and drop stored procedures, and we'll also go over insert, update, and delete. So here's an example. To create a stored procedure, you just create or alter procedure. Then you put all your parameters, and then once you want to execute that stored procedure, you can type execute, the procedure name, and then what you want to do with that procedure. To drop a procedure, you simply type drop procedure, and it's going to get rid of it. And if we go back down here, we can look at the insert. So this is the insert procedure. I can't rerun it, but if we look at everything previously, this supplier name, Augur, was not here, but we executed this insert and it put him into the table. And then for the update, I think it'll let me run it. Yes, this is the update procedure. So now if we execute this, as you can see now, there's not null values for Augur. It inserted, or updated, I should say, updated the current record with more information. And then lastly, we have the delete. So all this does is delete from the selected table and the selected column value. So, for example, this one would delete customer number 6. We can see if it works. First, let's select. And as you can see, customer ID number 6 no longer exists. Next, we can go over user-defined functions. So, what is a user-defined function? Though that can be described as accepting columns of input and then performing an action on that input and then returning the result of those actions as a value. So it can take in multiple values and then output one. There's two main benefits to UDFs. One is it's a good way to organize your SQL statements, and then two is that it's just results in better performance. It runs faster. And then differences between stored procedures and UDFs. So stored procedure can have a select, insert, update, and delete. A UDF can only have a select statement or select statements. Stored procedure can have both input and output parameters So then the UDF can only have input parameters. So let's look at some UDFs real quick. Here's a good example. So I can run this table. It's going to show me all the supplier IDs and all the delivery dates and all the other data, but all we care about is the supplier ID and delivery date. So here in this user-defined function, we want the supplier ID in the month, and then we only want the month of 10 and the supplier ID of 4. So in this user-defined function, as you can see, it requires both of them, the supplier ID 4 and the month of 10. So if we run this UDF, it's only showing deliveries with the supplier ID of 4, and as you can see here, month of 10 or October. And then same thing here, another user-defined function. It just wants the order ID. Let me see, what does it want? Customer ID of 1 and the year of 2017. So we can take a look. At the table. It has all the different quantities, all the different order dates with different years. And if we select the whole UDF, it's only going to show us the 2017 and customer ID of 1. Next, we're going to look at transactions. So what are transactions? Transactions are a group of SQL statements that you want to be, or that you want all to be executed together, or none of them to be executed at all. So there's 4 properties of transactions. We have atomicity, consistency, isolation, and durability. Atomicity is just basically all or nothing. Consistency means that the transactions may change the database state from one integrity state to another one. And isolation just allows the data access to be consistent, which the consistency it depends on the definition of consistency, which can be a little confusing. But next we have durability. That's the data saved in the database. So the data saved in the database should be the same even after something unexpected happens. Next, we can look at begin, commit, end, and rollback. And then we're also going to look at nested transactions and what save points do. So here we're looking at a transaction. As you can see, the transaction begins right here. And then it ends where it's committed. But if we have a rollback, then the transaction will not be committed. So let's run this one. Begin transaction. It wants to delete employee ID number 6. So if we take a look and see what happened. employee ID number 6 is still here. But for example, if we deleted this one, customer ID 4, since it's not a transaction, it's still treated as a transaction, I guess. It's just automatically committed. You can't get it back. There is no rollback. But if we did this transaction right here and we didn't do the rollback, it would essentially do the same thing as this one, because it would commit the transaction and actually delete employee ID number 6. So here is an example of a nested transaction. So it's 2 transactions nested together. Basically with nested transactions, even if the inner transaction works, it will not be committed unless the outer transaction works too. So here's a good example. We have a commit and a rollback. The commit is inside the rollback, but let's see what happens. As you can see, it did not delete employee ID number 2 or employee ID number 5. And this is where, if we want to commit a partial transaction, we can use save point. So save point is like a placeholder for a specific point that you want to start all over again. Here is an example of save point. So we begin the transaction, we delete employee ID number 2, and then we begin another transaction, but we save the transaction. So then whenever we come down here and roll back the transaction to save point, it doesn't roll all the way back, it just rolls back to this point. And let's see if this one works. So here's the table. Actually, let's run this. Might have ran that wrong. Nope, it still worked. So as you can see, it deleted employee ID number 2 because it only rolled back to this point right here. Next, we can talk about raise error. So error handling. Raise error is a statement. It allows you to throw an exception at runtime. So the statement accepts a string message with optional code number, level number, and state value. It's often used for custom errors. Next, we have blocking. So if a user is updating a row while another user is trying to read the data from the same row, the SQL server will block the second user to avoid the user from reading inconsistent data. So a deadlock basically can happen when 2 sessions are trying to access the same rows at the same time, but in a different order. So that results in the deadlock because nothing can essentially be done. So let's take a look. So here's a good example of a deadlock we did in class. It didn't work, but you get the idea. We have the data, and then where order ID equals 1, order ID equals 2. And then down here, we have another session. Order ID equals 2, order ID equals 1. So they're trying to access the same information. and then they're essentially supposed to print deadlock in session 1 and deadlock in session 2, because this is what a deadlock is, but it didn't work, but you still get the idea. Next, we're going to look at triggers. So, trigger is similar to a stored procedure. The biggest difference is that it automatically executes in response to certain events. So, such as like a record in a table being deleted, inserted, or updated. You could have a trigger keep a copy of a record inserted into the table for auditing purposes. If you delete a table that a trigger is based on, then the trigger will be deleted as well. So let's take a look at some triggers. So this trigger is really cool. It's the student audit. So basically, whenever you insert a new student with their GPA, as you can see here, student GPA, it's gonna also insert a log into the student audits table. So as you can see here, it also tells you audit action, audit timestamp, and then the login and the audit ID on top of all the other data. So let's run this example real quick. If we insert Rick, and then let's just select this one first. You can see he's inserted. And then if we select the audit, the trigger automatically inserted Rick into this table as well. And here it tells you what happened. So for example, this one says update a student, but since we inserted a new student, it says inserted. And next we have the the instead of trigger. So this allows you to do something different. Instead of inserting, updating, or deleting like a normal trigger, you can basically add code that rejects part of a row while letting the insertion of other parts of a row. So basically, you're telling it instead of just inserting, you could have it do a different function like update, or you could have it insert multiple things instead. So let's see, let's take a look at an example. I don't believe this one will run, but we can still look at the code. We have the trigger, and then here we have the instead of insert, and then we just have all this is just instead of insert. So instead of inserting, we want to display things like record inserted, insert a new student, and then we want it to display max seat must be greater than 10 or we want it to raise the error that displays that if the max seats is less than 10. So we can have all this go on inside of our instead of insert statement, instead of trigger. So it doesn't have to be instead of insert, it could be instead of update or instead of delete. Next, we are going to look at DML versus DDL triggers, or more specifically, just talk about them. So DML triggers work on the table level. Basically, everything we just looked at. And then DDL triggers happen when an event in the database happens. So, for example, you could have a DDL trigger that doesn't allow the creation of new tables, and it would roll back the database if a create table statement is executed. So DDL has to do with on the database level compared to the table level is the biggest difference. Then lastly, dropping, disabling, and modifying a trigger. So when a trigger is dropped, all properties of the trigger are gone. If you want to disable a trigger without deleting it, use disable trigger. Alter trigger allows you to modify an existing trigger without losing all the properties already established on the trigger. So lastly, we just have alter table. With altering a table, it basically allows you to add, drop, or modify, or even rename a column of a table. So, for example, really all you need to do is put the command alter table, put the table name, and then use drop column, and then you could put something like address, city, name, delivery date, whatever column you wanted to drop. Or you could add a column, or even change column names if you wanted to do that. And that's basically it.